Okay, so the basic idea of the monopoly model is that firms want to try to reduce their quantity in order to raise the price that they receive for their goods in the industry. And the reason is that in order to sell more units, a firm needs to lower its price, but not just on that last unit, but on all of the units that the firm sells. And this, of course, wouldn't arise if firms could charge different prices to each purchase and each purchaser, which is something we'll talk about just after the midterm. Okay, so the monopoly will tend to reduce quantity below the point where price is equal to marginal cost. And that basic effect is something that shows up all over the world. So, Adam, could you give me some examples of cases where firms with market power reduce their quantities below what you might think is an efficient level?
Well, maybe something like if you like a organization like a union or something as like a kind of like a monopoly of the labor.
Yeah.
So like they might have like they may try to like impede others entering into the labor field or have some like license for the job.
Yeah, that's a very good example. Occupational licensure. We didn't talk about that in the first class. We did in the previous years. Labor unions who try to stop immigration or have closed shops that stop people from competing. Farm cooperatives try to prevent overproduction of farm products. Drug cartels' main job is not to produce drugs, but to stop other people from producing drugs. And this is the reason that when the drug baron Pablo Escobar was killed, the price of cocaine fell precipitously rather than rising. Drug companies make massive investments in trying to reduce the supply of the goods that they sell by stopping reimportation from poor countries of their products, strictly delineated territories, etc. Digital materials of all sorts are basically free to copy, but not free to copy because the law tries to stop you from doing that, and companies invest a huge amount in trying to reduce the quantity that's supplied. Movie theaters, it basically costs nothing if a movie isn't sold out for an additional person to come, and yet they keep people out by charging a price, which is also obviously inefficient. Okay, so to represent this, let's say that the revenue that a monopolist earns, R of Q, is equal to their price, which depends on quantity times quantity. Now, under perfect competition, they would set price equal to marginal cost, and now they're going to set marginal revenue equal to marginal cost. Marginal revenue is just the derivative of the revenue, and where's Joan? There she is. Hi. By the product rule, what is the derivative of revenue? What's the marginal revenue equal to?
PQ plus derivative of PQ.
So PQ. So what's the derivative of P of Q times Q?
Yeah, PQ plus derivative of PQ with Q times Q.
Yeah, so, P of Q. Yes. P of Q plus P prime times Q.
Yeah.
That's right, absolutely. So there are two terms here, because you're going to set this equal to marginal cost. Now, if this first term was the only thing here, then you would set price equal to marginal cost. That would be good, right? This is what happens. This is the term that comes from how much benefit the firm gets from changing its quantity, holding the price fixed, taking itself as a price taker. But there's a second term that comes from the impact it has on price experienced on all of its inframarginal units. That's the second term, which is called market power or the Carnot distortion, or sometimes the marginal surplus of consumers. Because what this term is how much, when the quantity increases, consumers benefit, which the firm doesn't get, right? So the price is the marginal value that consumers place on getting the product, but not all of that goes into revenue. Some of that goes into consumer surplus, and that's exactly what this term is here. Okay. So this term is proportional to how many inframarginal units the firm has and how much it impacts price. And those are both measures of how large the firm is. If the firm is very small, it will have little impact on price, and will have few units on which to have that impact. Okay, so let's derive some simple examples of this for the most common demand curves. Let's first start with a concave demand curve. Philip, could you derive the marginal revenue curve corresponding to this demand curve?
Should I go up to the board?
Sure, that's probably easiest for people to follow.
Alright. Where is the
Oh,
here?
okay.
I can erase it.
Yeah, please.
Okay. So MR to a piece of Q equals piece of Q equals 1 minus Q squared, right?
Yeah?
And then revenue equals QP equals Q 1 minus Q squared equals Q minus Q cubed.
Exactly.
And so MR is just the derivative, which is Q minus 3Q squared.
1 minus 3q squared, right?
Correct. Yeah.
Exactly. Well done, Philip. Thank you. Okay. So, let me show you what that looks like. So here's the concave demand function. And you see that as the quantity increases, initially marginal revenue and price are at the same point, but then they diverge increasingly rapidly as the quantity increases. Okay. Andrew Adair is not here. Can someone else derive this for linear demand? Suel, yeah.
Sure, so first you find revenue, which is 1 minus Q times Q, so that's Q minus Q squared.
Mm-hmm.
Take the derivative of that, you get 1 minus 2Q.
Exactly. So this is steeper than demand is. So here's linear demand. This is steeper than demand is, but it diverges at a constant rate, right? Whereas this diverges from demand at an increasing rate. Okay. How about exponential demand? Rishi, can you derive?
Sure.
Yeah, sure.
I'm just gonna write up here.
Yes.
Cats is awkward. FP cubed was 1 minus log Q.
Yeah.
So you've got Q times PP equals Q minus Q log Q.
Mm-hmm.
And can I erase this part? Is that
Yeah. I don't think we have an eraser again.
I just
Oh, there it is. Yeah.
Oh, so that. Alright, so then if you derive this, you get 1 minus, and then particle of this. So you get Q times 1 over Q
Yeah.
plus,
No, I think he's got a minus around the whole thing. Yeah.
and then log Q times 1.
Yeah.
So you get 1 minus 1 plus log Q, which is equal to log Q.
Exactly. Actually, negative log Q, but
Oh, okay,
yeah,
because this was negative.
yeah, but no, that's right. Okay, so this one, notice that that's like log Q, and it was 1 minus log Q. So this is just by a constant below price, right? So that is shown in this graph here. You see there's always a constant distance between marginal revenue and price. So here they were diverging at an increasing rate. Here they're diverging at a constant rate. here there's a constant distance between them. So guess what's going to be happening with the last case that I give you? Rishi, I'm going to call on you again. Do it for the constant elasticity too.
All right. Not critical, handicap. All right. Cool. So I'm just gonna erase what I did. So we have 1 over q to the 1/2, right?
Yeah.
Which is q to the negative 1/2.
Yeah.
So, sorry. So if you take q times q, you get q times q to the negative 1/2, which is q to the 1/2.
Yeah.
And if you derive this, you get 1/2 q to the negative 1/2, which is equal to 1 over 2 root q.
Exactly. So notice that this is half of the price, right? And it's decreasing in quantity. So that means that these things are going to converge together over time, right? Because there's a constant ratio between them rather than there being a constant difference between them. So that's shown here. You see they're further apart up here because the ratio between the two of them is always constant. Okay, now how do we find optimal quantities? Well, imagine that the marginal cost were the x-axis here, just for fun. Then you intersect that with the marginal revenue curve. You draw a line up to the demand curve and left over to price in order to get the optimal price for the firm to charge. Okay. Now another way to write marginal revenue is as price times quantity, price of quantity times 1 minus 1 over the elasticity of demand. And Rishi, I'm going to have you derive that again as well. I swear it's random.
Oh, 1 minus 1 over epsilon, is that?
Yeah?
Okay.
No, it's not P of Q equals that. It's marginal. I want to claim that marginal revenue is equal to P of Q times 1 minus 1 over epsilon. The question is, how could you prove that that's the case? Times P of Q.
Oh, times P of Q, sorry.
So we had a formula for marginal revenue before. Can you transform it into that?
Okay, so we had from before that marginal revenue equals P prime of Q plus...
It's P prime of Q times Q.
Oh, sorry, I quit. P prime of Q times Q plus P of Q?
Yeah?
Okay. So if you...
Well, here you've got your P of Q term, right, which shows up there. So this much must correspond to this term somehow, right?
Okay, so I mean, if you get your, because you don't have a P of Q, unless you, I don't know, sorry.
So why don't you try factoring a P of Q out of the whole expression?
A P of Q?
Okay.
Okay. Then you get 1 plus P. So,
Yeah.
1 plus
P prime of Q.
P prime of Q over P of Q. Okay.
Now,
Oh, okay.
does that look like an elasticity?
Yes, it is. So, right, which we got which is equal to, yeah, P of Q times 1 plus 1 over epsilon, right?
Except that the elasticity of demand is negative, so yeah.
So 1 minus 1.
Exactly.
Okay.
Just to be a little bit more explicit, this is dp dq, which is 1 over dq dp, right? And then it's divided by, q and multiplied by p, and that's exactly the elasticity formula.
Okay, what did you say?
No, you're done. You're done, my friend. Okay. So one thing that immediately tells us is that marginal revenue is negative whenever the elasticity of demand is less than 1. Which means that the monopolist will never produce in a region where demand is inelastic because he'd always have an incentive to reduce his quantity, which would also reduce his cost. So the elasticity of demand can be seen as one way of formalizing the notion of monopoly power. If the elasticity is small, then the relative importance of that firm is small. If the elasticity is large, that firm is relatively important to the market, and it summarizes the notion of being sort of a big player. And rearranging this, setting this equal to marginal cost, yield that the price minus marginal cost divided by price, that's called the relative markup, is equal to the inverse elasticity of demand. So the smaller the elasticity is, the larger the markup the firm charges, which is a natural measure of monopoly power. Okay. Now, of course, there's other measures of market power you could also create. It's not obvious this is the best one. Another one you could create is the markup divided by the marginal cost rather than divided by the price, and that's equal to 1 over the elasticity minus 1. Or you could do the price to marginal cost ratio, which is equal to the elasticity over the elasticity minus 1. Or you could do the absolute markup, which is equal to the price divided by the elasticity. These are all very similar ways of measuring market power, and some are more useful than others depending on the context. So the standard learner formula is useful because it's so simple and it uses elasticity so directly. The price-cost ratio is useful for profits, especially when you have constant marginal cost, because it yields just like the ratio between whatever the cost is and however much profits the firm is making. The markup to cost gives a measure of profitability. The absolute markup is useful when costs are not positive, which can happen, for example, in credit cards. Your credit card subsidizes you for using your card. You get points for using your card because they're earning money off of interchange fees from merchants that pay them when they use the card. And so denominating things by cost can be problematic then. Okay. Now, of course, to set these prices, firms need to know what the demand curve is. Otherwise, the quantity that they produce will not match demand. And so as a result, firms need to be able to draw out their marginal revenue curve. And it used to be that firms just had to guess about this and gradually learn. But the internet has really created a revolution in this extent because many companies are experimenting with prices all the time to try to figure out what demand is. This is particularly common on eBay, where sellers all the time are experimenting with the reserve price that they can charge in their auctions. Sometimes the same seller will sell the same good on a different day or even at the same time at different prices or at different reserve prices in order to try to see what demand is like. Now, this is an auction. Yeah, Christian.
Sorry, what's the reserve price?
A reserve price is the lowest price that you'll accept without calling the auction off.
Oh, okay.
So it's like a starting price, basically. Now, changing the reserve price is a lot like changing a price, and it traces out something like a demand curve. Why is that true? What sort of demand curve could you create, Evan, using changing around the reserve price to affect prices and the probability of sale?
So you want me to explain why it would look like a demand curve?
Or what? Yeah. How? This is a starting price for an auction. It's not like a price that I charge, and the number of sales I get. But you can get out of this something that's like a demand curve.
Well, instead of the number of sales, you could look at, for example, the number of people who are going to be willing to bid,
Mhm.
or you could look at what kind of price of how much you can expect it to go up, right?
Mhm.
Or if it's going to, or the probability of it that's going to actually clear.
Yeah, so I think the easiest thing to correspond to is the probability that it actually clears, right? Because if you set a higher reserve price, the chance that it clears is going to be lower. But what's the offsetting benefit you get when you set a higher reserve price?
You get more money.
Why?
The reason why you get, well, I suppose it's that you're more likely to get more money, right?
Yeah.
And the reason why is because, let's suppose that you have one auction where you have the same item with a lower reserve price, and you have, for whatever reason, one person who bids that lower reserve price. In the first auction, that's what you're going to get.
Yeah.
In the second auction, if that person is still willing to pay
Yeah,
higher,
exactly.
then you get that money. You can't get the lower one.
Exactly right. So basically, there are two circumstances where the reserve price matters. One is one in which if you'd set a lower reserve price, someone would have bid above it, but because you set a higher reserve price, no one bids above it. That's the case in which the reserve price deterred a sale from taking place. On the other hand, there's another circumstance, which is that the second highest bid, if there was one, was below the reserve price that you set, but the highest bid was above it. In that case, it raises the price that you get. And so you can look at the average price that you get for a good as a function of your reserve price, graphed against the probability of sale. And those things will have a negative relationship. The higher reserve price you set, the higher average price you'll sell it at, but also the lower will be the probability of sale, and that'll trace out something like a demand curve. Yeah, Austin?
This is not, I guess, strictly the same thing, but I know on eBay typically they'll tell you whether the reserve price was met or not, whereas like in art auctions and things, it's typically private, they don't tell you what the reserve price is. Do you get any like discontinuities related to that? People, just trying to barely clear it or something?
So people always barely, it's always people's incentive to first barely clear it. In the art auctions, that incentive doesn't exist, and a reserve price doesn't actually raise your revenue. All it does is stop the thing from being sold at an inefficiently low price. So, yeah. Okay, so Laurent Einav, Teresa Kuchler, John Levin, and Neil Sundaresan got all of eBay's data. And they found 500,000 cases in which people had run experiments. So you guys probably know John List here runs lots of experiments, right? But what they found was that you don't just need to be an economist who goes out and runs experiments yourself. Sellers on eBay are running experiments all the time. And so rather than running, 5 or 10 experiments, you could look at 500,000 experiments by looking at what the sellers are choosing to do themselves. And so what they did is they looked at cases where the same seller sold the same item on slightly different terms, either at the same time or at slightly different times. And they used this to draw out demand curves for the auction, just as I was describing. And the interesting thing is they found that all these demand curves had a very similar shape. Yeah, Evan?
So on eBay, is there a penalty for listing the same item multiple times and then canceling the $999 to get the lowest price before they close?
Oh, I think there is, yeah.
So
you have to agree to sell.
So then what are they doing? Are these sellers who have an inventory and then list the inventory?
I think that's the point. They're trying to figure out what the market price should be by trying out different prices.
And then for the future.
Yeah. So the interesting thing that they found is that marginal revenue is actually increasing in some parts. And so the cost, if you think about it in this case, is the value you could get by trying to sell that object again or keeping it yourself, right? And there's a possibility of there being multiple intersections between marginal cost, which is constant as a function of the probability, right? It's just the value of that good, and the average and the marginal revenue. Okay, so let me show you a picture of this and show you what we do to analyze these cases. So here's what they found. They found that for tons of different goods, if we divided the price of the good by the assessed value, that the demand curves looked very similar to one another, and they looked like this. They were sort of reasonably sloped here, but then they get incredibly flat as you get out to high probabilities. Why is that? Well, as an object is getting down to a low probability of, a low price, there's always going to be someone on eBay who's just looking for deals, who's going to snap that thing up and go resell it, right? And so that makes demand really have a very sharp floor underneath it. These people up here are people who are actually going to keep that good. These people down here are people who are just going to go and resell it again, right? You can fit a curve through this. You can just use polynomial fit on Excel, and you can fit a third-degree polynomial through this, and you get a marginal revenue curve that is not just decreasing like all those marginal revenue curves we looked at before, which means that if you had a marginal cost that was right here, there would be 3 intersections between marginal cost and demand. Now, does anyone want to guess? Imagine that marginal cost were here. Which point of these 3 would actually be the optimal quantity for you to sell? The optimal probability with which a sale would occur.
Marginal cost is where again, sorry?
Marginal cost, let's say it's at 0.75. So it's just below that black line that I drew. What do you think, so?
Is the area, like, are those 2 little regions, like that,
Yep.
between the pink and the black line, are those equal?
Yes, that's the point. But you have to figure out why that's the case. That's what I'm trying to take you guys through now. Well, notice that the profits that a firm earns is the area between the marginal revenue curve and the marginal cost curve, up to the point that they go to. So if the firm produces here, they get all this area in profits, but they don't get anything over here. If they produce over here, they're going to actually take losses in this region down here, and then they'll make gains over here. But the gains are bigger than the losses here, right? The area above is bigger than the area below, and so they'll produce over here. On the other hand, if they had a cost that was 0.85, like up here, then if they produced over here, they'd take losses over this full region here and only make gains over here, which would not be worth it, so they'd be better off producing over here. So this line, which is called the ironing line, is the line where area above the line and below the curve equals the area below the line and above the curve. And that is exactly the cost at which they would jump from selling with this probability to selling with this probability. So if someone's cost went from 0.79 to 0.82, you would see the price jump from, on average, from about, 0.82 up to 1.05, right? So there would be a discontinuous change in price when there was a continuous change in the cost. And the reason is that you're basically making a decision of which of 2 markets to serve. Are you going to try to just give this to the resellers and let them resell it, in which case you'll set basically a 0 reserve price? Or are you going to try to really sell this to a final consumer only, in which case you'll probably set a reserve price that's about equal to its value? Does that make sense? So this technique, ironing, is a more general technique you can use. Anytime you have a non-monotonic marginal revenue curve, or really non-monotonic anything function that you have to optimize in economics, you can always replace it with a monotonic one by using ironing procedures like this, canceling out the area above and below. Yeah?
I think that the ironing line was determined by who wants to resell versus who wants to keep it finally. Could you just talk a little more about that?
Well, so, this is just a hypothesis, but the reason these demand curves, look, they have this shape where they're like quite steeply decreasing, and then you get out to about a 0.5 probability of sale, and they're almost totally flat after that. And the reason, I think, is that basically the people who are buying it and showing up with about 0.5 probability are people who actually want to keep that thing forever. And they have like a decreasing demand curve. But people who just want to resell it, their value is completely constant because they all just have the same cost of reselling it, right? Okay. So monopoly has two basic welfare-related effects compared to competition. The first is that it transfers resources to the monopolist from the consumers. And the second is it inefficiently reduces the output in the industry. So how do we know, Mike Fosco, how do we know that this reduction in quantity is socially inefficient?
From the deadweight loss, where they're not producing where marginal cost is equal to the price they're doing less than that.
Okay, so why does that create deadweight loss?
Because there are more gains to be made for society in general if you produce more output, because then the benefit to the consumer is greater than the lower benefit to the provider.
Yeah, so basically this is a case in which at price equals marginal cost, the value the consumer gets is exactly equal to the cost to the firm of producing. If the price is above the marginal cost, the consumer gets a greater value out of the product than the cost of producing it, and therefore it would be socially valuable to produce more of it. And the firm is eliminating some sales that would be beneficial because the benefit to the consumers would be greater than the cost. Okay. Now, the inefficiency of monopoly, I think, is quite apparent in real life. It's the reason why information goods like music aren't freely available, right? It's the reason why there are empty parking lots in busy cities that charge high rates, right? Like, it's completely crazy for there to be parking lots that are empty and people who are roaming around the streets looking for places to park, right? Because there's no cost of on the margin of putting one more person into that parking lot, and there's a big cost of having them roaming around the streets, right? Yeah, Evan.
Couldn't you see the high parking rates as just a fee of the people who are going to park in that area are paying to increase the probability there is a spot? Because I'm from one of those very crowded areas, and it's not normally the case that people are driving around because there's not a spot in the parking lots, because even with high prices, it's usually full.
Really? I don't think that that's true. I don't think it's usually true that parking lots usually have a fair number of vacancies in almost all times of the day. I mean, there's a few parking lots that fill up at a few times of the day, but it's very rarely the case that all the parking lots are actually full. So, yeah, Austin.
Are parking lots really monopolies though? I mean, I feel like for parking lots at least, it's more of the case where it's...
Yeah, so that's a good question. I don't think that structurally they're monopolies, but I think it's basically they are monopolies because once you've turned, you can't figure out what the price of the parking lot is until you've already turned into the parking lot. And then, I mean, in other words, like people have to invest like resources to learn the prices of the parking lot. If there was complete price transparency, I think it would effectively be perfect competition. And I think that's starting to happen because of this app, Best Parking. I don't know if you guys have this. I love this app, and it like tells you the rates of all the parking lots. And I think if everyone comes to have that app, then there will be perfect competition. But I think that not everybody has it yet, and so there is effectively monopoly.
Are there any dynamically priced parking lots in Chicago?
Well, I mean, there's almost all parking lots have some amount of dynamic pricing. Right. They all have like, you know, special deals, but not really intelligently dynamically priced ones. No. I mean, they're like the way they dynamically price is better than none, but it's not as intelligent as you could with a really adaptive system. But to really make something like that work, you'd need price transparency on that as well. So you'd need to have like the app linked to the prices, and people would have to like have their apps telling them which lot to go to based on its current, you know, occupancy and therefore price.
I think I read San Francisco's doing that now.
Yeah,
really?
I think cities in California are trying that.
100%.
Yeah, what things isn't California doing better than the rest of the world? I mean, I'm a Californian. Okay, so effectively, monopoly means that consumers have an externality on the firm. Because if they purchase more, the firm is going to make more profits because the firm is earning a markup over marginal cost on every unit that it sells. And these extra profits that are created are not mediated through the price system, so they're a real externality. And they suggest as standard Pigouvian solutions like subsidizing purchases of the goods by consumers, or perhaps regulating the firm's price down to cost, or mandating an efficient quantity to be produced. And we're going to talk about some of these policies in practice on Thursday, but they're far less common than you'd think. And in lecture 13, we're going to talk a little bit about why, despite the ubiquity of market power, we don't have solutions that really address them that often. Now, another thing to keep in mind is that there are other solutions that you could use to address market power, which maybe seem a little bit more dirty or less cleanly lined up with economics, but are, from a social perspective, just as valuable. So, for example, advertising or creating prestige for products can make people value them more. And that can cause consumers to buy at prices that are above what they're willing to pay, and therefore offset the distortion associated with monopoly. So some sort of deceptive advertising or building hype around a product might actually be socially beneficial because it offsets the monopoly distortion.
We consider that paying more than they're willing to pay?
What?
Like, that's considered paying more than they're willing
Well, I mean, imagine a lot of people say, oh, they trick you into making you feel like you want the product when you don't really want it, or you're willing to pay more than you're really willing to pay. But that could actually be good in the context of a monopolized product, because otherwise it would be inefficiently underconsumed. Yeah, so.
Like in that scenario, though, although you'd be producing the right output, like the right quantity, like the benefit would be transferred from like consumer to the producer.
Yeah, that's true.
Okay, so.
But still, from a social perspective, in aggregate, it's still valuable. And in fact, it might even be good to transfer it to the firm if the firm innovated in order to create that product, because that gives more incentives for innovation. Yeah, Evan.
Why is it that the socially optimal quantity hasn't changed in response to the advertising? Because if now you change how people value it, why?
Well, I mean, it all depends how you think about advertising. But some people think about advertising as sort of deceptive and making you feel like you want something more than you really want it, and that wouldn't change the socially optimal quantity.
So you're saying that if you think of it as there's like still a constant real want?
Yeah. So there's a paper by Dixit and Norman, which is all about that. Yeah. So,
if we assume that people have a constant real want, then being able to deceptively advertise essentially it allows the monopolist to appropriate some money that is that consumers really aren't willing to pay. So might it create too much incentive?
Yeah, so you'll typically you'll spend too much on advertising, but it will also typically be bad if you don't allow advertising at all. So, okay. So like any tax or externality, the value of extra production will be equal to the wedge, the sort of difference between price and marginal cost, times the change in quantity that occurs when something changes. Yeah, right?
So even though that allocates a socially optimal level,
Yeah.
does it still create a negative externality because consumers buy more than they
So advertising will have a negative externality because you'll be taking money from consumers and giving it to the firm. And it's an action taken by the firm. So it does have a negative externality, but on the other hand, it might be more efficient than completely banning that activity. So you might want to tax advertising, but you wouldn't want to eliminate it entirely. Yeah, Christian?
So would that be a real externality of advertising?
Yeah.
Can you?
It's real because it hurts the consumers, but it doesn't benefit anyone other than the firm. And so...
And the firm's the one doing it.
Yeah. Okay. So as a result, we can measure the deadweight loss using the standard deadweight loss triangle. The only difference is now the size of this triangle is determined by the monopoly optimum. And in particular, it has a particular relationship to monopoly profits that we'll explore in a minute. And this is the triangle bounded by the supply curve, the demand curve, and the equilibrium quantity. Now we can measure monopoly profits graphically in two ways. One is the area between the equilibrium price and marginal cost, or the area between marginal revenue and marginal cost. So let me show you that. So the area between price, so if this is the marginal cost curve, and this is the marginal revenue curve, here is the price, and profits are either the area between this price and marginal cost, C plus D, or the area between marginal revenue and marginal cost, which is A plus C. And you notice by similar triangles, these are the same areas.
Wait, what is each line represent?
So this is the demand, this is the marginal revenue, this is the marginal cost. So this is the optimal quantity and the optimal price. So here's profit, the area between price and marginal cost, or profit, the area between marginal revenue and marginal cost. And they're the same by similar triangles. We can also measure consumer surplus as either the demand between the area between demand and price. That's the way we usually measure it. That's A plus B up here, right? But you can also measure it as the area between demand and the marginal revenue curve, because remember that the difference between demand and marginal revenue is the marginal surplus of those consumers. So that's the area B plus D, which again by similar triangles is the same as the area A plus B. Okay. The deadweight loss triangle is E, the area over here, because this would have been the efficient quantity, and here's all the loss in willingness to pay minus marginal cost that occurs between those. Okay. Now, Alfred Marshall, who is not only one of the most famous economists of all time, but also was sort of the founder of price theory, which is the school of economics that the Chicago School is so into, said that you can think about almost everything in economics in terms of tax incidence. And you probably learned in both your basic courses and probably last term the basic principles of tax incidence for perfect competition, and use those to think about all sorts of different types of interventions that happen in markets. Now, most of what's different under monopoly, remember that monopoly models are really only useful for thinking about interventions that occur directly through the actions of that firm. And so if we just think about the incidence of changes to that firm, we can think about most interventions that are relevant to monopoly. So I want to give a brief recap of perfectly competitive incidence, and then I want to contrast that to monopoly. And Evan, could you tell us some of the principles of incidence under perfect competition?
Principles of
Incidence of taxes.
Can't remember it.
Anybody else want to? Yeah, Philip?
In the short run, because, well, in the long run, the incidence is purely on consumers because firms need to enter and exit to maintain zero profits and equilibrium.
Well, if in the long run the supply curve is extremely elastic and the demand curve is not so elastic, but
yeah, assuming infinite, using the standard elasticity assumptions.
Yeah, but I mean even more basic than that. Tavish?
Whoever has the more inelastic supply or demand curve will bear more of the burden.
Yeah, that's one of the most basic principles. So the most basic principle is that the physical incidence who literally pays the tax is irrelevant to who actually bears the burden of the tax. Because if we charge tax on the consumers, the price of the good will fall. If we charge tax on the producers, the price of the good will rise in response to that, most likely, right? And so therefore, we can always treat the tax as if it's directly paid by the producers, and then just study how it gets passed through to consumers. And I'm going to call that rate of pass-through, the rate at which the price increases when the tax increases, dP/dt, the pass-through rate, rho. So then, the fraction of the tax that ends up getting paid by the consumers is going to be equal to the pass-through rate, and the fraction that's paid by the producers is 1 minus the pass-through rate, right? And all of the tax is borne by one side or the other, right? If we have put in a small tax, all of that tax is borne either by the consumers or the producers. So if we want to call the incidence the ratio of the amount borne by the consumers to the amount borne by the producers, that will be rho over 1 minus rho. Okay, so the second principle, and this is what Tavish was getting at, is that the inelastic side of the market bears the tax. And in particular, the pass-through rate is equal to 1 over 1 plus the elasticity of demand over the elasticity of supply. And Tanner, could you derive that formula? You'll probably want to do it on the board.
Yeah, sure.
Yeah, please. There's a eraser if you want it.
Where's that? So I'm driving the price 1 over 1 plus the less demand over less supply, right?
Yeah.
Okay.
It's the pass-through is equal to 1
Oh,
over.
pass-through, right. Yeah, sorry.
So to derive the pass-through rate, remember you need to do a comparative static. It's how does the price change when the tax changes, right? So what's the equilibrium conditions in the market? It's demand equals supply, right? But remember that the producer doesn't get the full price. He only gets the price minus the tax. So how would you set up the equilibrium conditions for that?
Let's see. So the producer gets the price minus the tax. We want to find the change in price as the tax change. The change in price of the tax happens.
Yeah, so what's first just write down the equilibrium condition. So demand is a function of price. Just D of P, right? That's just a function, D of P. No, D of P, like demand of price, is equal to the supply as a function of price minus the tax, right?
Right, yeah.
Okay, so now how would you figure out how the price changes with respect to the tax?
Take the derivative of both sides.
Yeah. So by the implicit function theorem, you have to put dp dt here,
All right, yeah.
and you have to put dp dt minus 1 there. Yeah, you have to put parentheses around all that.
So
Okay, so now you need to solve for dp dt, which is the pass-through rate. Good. If you can drop the arguments inside of those things, it'll make your life easier. Right? Okay, and then try dividing through both the top and the bottom by S prime.
by S prime.
Yeah. No, don't divide both sides. Just divide the top and the bottom of this expression by S prime. Yeah, D prime over S prime. Yeah, you also have a negative there, so you have to reverse those, but yeah. And then put a negative in front of this. Yeah. Yeah. And then note that D prime over S prime is equal to the elasticity of demand over the elasticity of supply, because both have the same price and the same quantity, right, at equilibrium. And so that's how you get this formula. Heroic job, Tanner. Thank you. Okay, so just to give you an intuitive sense for this, suppose that the demand curve is totally inelastic and the supply curve is somewhat elastic. Then look, the consumers are going to bear all of the tax. If we put the tax on, the price rises exactly by the amount of the tax, and the consumers bear it all. On the other hand, if the supply is perfectly elastic, and then when the demand is perfectly elastic, then when the supply, when the tax rises, the price is going to, then the price is going to stay the same, and the amount received by the firm is going to fall by exactly the amount of the tax. And therefore the firm will bear all the incidence, right? Now more generally, if both are elastic, it depends on the relative elasticity of the two curves, as shown here. Okay. Now, if we keep raising the tax on a market, if we start with a small amount and we raise it higher and higher, at some point we're going to reach a tax that's so high that no one's willing to buy the product at all anymore, right? And we can work backwards from that point to determine the total amount of consumer surplus, right? So because once we reach a tax of T, there's no consumer surplus, the consumer surplus is just going to be the integral of the pass-through rate times the quantity, because that's how much the consumers lose every time we raise the price by a little, the tax by a little bit. And the producer surplus is going to be the integral of 1 minus the pass-through rate times the quantity. So if we then let the average pass-through rate be the quantity-weighted average of pass-through between a tax of 0 and the maximum tax, then the global incidence, the ratio of total consumer to total producer surplus, is the ratio of the average pass-through over 1 minus the average pass-through, right? So, you know, often when you say the consumer bears the weight of a tax, you want to think, oh, poor consumer, he has to pay all the tax. But in reality, the only reason the consumer is bearing the weight of the tax is that the consumer is the one who benefits from the market existing in the first place, right? The person who bears the tax is the person who benefits from the market being there, right? So the global ratio of consumer to producer surplus is just the quantity-weighted average of the ratio that happens for a small change in the tax rate. So the inelastic side is the one that benefits from the market existing. They're the ones who really need it to be there. Whereas the elastic side doesn't care whether the market's there or not. They're just as happy either way. Okay. Now, under monopoly, there's going to be a fundamentally, incidence is going to be fundamentally different in a couple of ways. So it's still going to be the case that physical and economic incidents are independent of one another, because it doesn't matter whether you tax the consumer or the producer. But now, rather than the tax being split between the two sides, there's actually going to be an excess burden. Because too little of the good is already being produced, there's going to be more loss to the firm and the consumer than is the revenue that the government gets. In particular, the firm chooses its quantity so as to maximize prices. And its profits are given by this formula. So what is going to be the loss to the firm when the taxes increase by a little bit? Rishi? And you can use the envelope theorem. See if you can use the, no, don't look. See if you can use the envelope theorem to figure out, really simply, what the effect of a change in the tax is on the firm's profits in this case.
Yes, by the envelope theorem,
Remember, the quantity is being chosen optimally, right?
right. So if the tax changes by a very small amount, the quantity also, the quantity also changes by a very small amount. Is that
That's true,
okay?
but it's not enough. What does the envelope theorem tell us to do?
To differentiate with respect to the quantity, with respect to optimal quantities.
Yeah, it says that we can hold fixed anything that's being optimized
Right.
when we take the derivative of the thing that it's optimizing.
Right.
So here, what would that tell us the effect of the tax on profits is?
So you can hold profits.
You can hold quantity fixed, because that's the thing you're choosing to
Okay,
optimize.
you can hold quantity fixed. So would it just be holding quantity fixed? Would it just be the derivative with respect to
T directly, right?
So it would just be negative, just Q minus,
Just negative Q.
just negative Q.
Yeah, so the monopolist, because he chooses his quantity to maximize profits, bears the full burden of the tax.
Oh,
He gets exactly negative Q. That's the full amount of revenue raised, right? And he bears all of that directly, right? But the consumer still loses the pass-through rate times the quantity, right? Because if his price rises, he's worse off, and it will typically rise, right? So the excess burden then is rho times Q. So everything, the burden is fully borne by the monopolist, and then it's additionally borne as excess burden by the consumer. Therefore, the incidence, the ratio of how much the consumer loses to how much the firm loses, is the pass-through rate divided by 1, or just the pass-through rate, right? And again, we can integrate this up as before to get the ratio of consumer to producer surplus is the average pass-through rate. Okay, so just to see how this works, here's a monopolist, here's his marginal cost. Imagine now we shift up his marginal cost with a tax. How much does he lose in profits? Well, profits is the area between marginal revenue and marginal cost. And that's fallen by the quantity multiplied by the change, right? Now there's a little extra triangle here, but that's very small. That's second order. Okay. So under monopoly, the logic of incidence is therefore different in two ways. So one is that there's this extra dead weight loss so that the incidence is not just split, but there's this excess burden. And the second thing is that the marginal revenue curve, and not just the demand curve, will help determine the pass-through rate. So now I want to consider the pass-through rate. So Tanner very nicely derived for us the pass-through rate under perfect competition. Let's do the same thing for monopoly, right? For monopoly, marginal revenue is equal to marginal cost, which also includes the tax. So implicitly differentiating, we get that marginal revenue prime multiplied by the derivative of quantity with respect to the tax is equal to marginal cost prime times the derivative of quantity with respect to the tax plus 1. And the derivative of quantity with respect to the tax is therefore equal to 1 over the derivative of marginal revenue minus the derivative of marginal cost. Now, how much does that lead to a change in price? Well, how much does price change when quantity changes? Well, it's just the derivative of price with respect to quantity. And so the pass-through rate is P prime over MR prime minus MC prime. Now remember that MR is equal to P plus P prime times Q. So if we let the marginal surplus, as we were talking about before, be equal to negative P prime times Q, and we identify the marginal cost curve, remember that the supply curve is just the inverse of the marginal cost curve. So we can identify the supply curve with marginal cost curve. then marginal cost prime is equal to P over Q times the elasticity of supply, just by the same logic we did to derive the elasticity of demand in the Lerner index before. And P prime is equal to negative P over Q times the elasticity of demand. Then we can replace all these terms with these here. And we can divide through to give that the pass-through rate is equal to 1 over 1 plus the elasticity of demand minus 1 divided by the elasticity of supply plus the 1 over the elasticity of the marginal surplus function. Now this is basically similar to what we saw before, right? There's still 1 plus the elasticity of demand divided by the elasticity of supply. There's a negative 1 in here, which is not all that important. But the key new term is the 1 over the elasticity of the marginal surplus function. So the question is, how should we interpret this elasticity of the marginal surplus function? Kim, do you have any thoughts about that? No? Anybody else? Like, we saw how the marginal surplus function was behaving before, right? It was that area between the demand and the marginal revenue, and we saw that it was doing different things depending on the demand curve that we looked at. Well, so the 1 over the elasticity of the marginal surplus measures the curvature of demand. It's going to be greater than 1 for concave demand. How do we know that? Well, remember, as quantity was increasing, that distance was increasing more than 1 for 1 when you had concave demand. It wasn't just linearly increasing, it was increasing at an increasing rate. So that means it had an elasticity greater than 1. With linear demand, it was increasing at a constant rate. So that means it had an elasticity of 1. And for negative exponential demand, it was completely constant. So that means it had 0 elasticity, right? For log convex demands, like the marginal, like the constant elasticity demand, it was actually decreasing. And that means it has a negative elasticity, right? And if this is negative enough, then the pass-through rate can even be infinite. How do we know that? Well, remember that in the Einov et al. Example, right, we had that ironing line so that a small increase in marginal cost could lead to a discontinuous increase in price. That's an infinite pass-through rate. And that came from the fact that that marginal surplus was shrinking very quickly as the quantity was increasing, right? So in addition to the elasticities of demand and supply, we now are going to care about the curvature of demand as well. In particular, when demand is concave, when it's negatively curved, the elasticity of marginal surplus is going to be positive, and that's going to tend to make the pass-through lower. And when the elasticity and when the demand curve is convex, it's going to tend to make the pass-through much higher. Now, what are some ways that we might think about circumstances in which the curvature of demand might be positive or negative? Kim, do you have thoughts about that? It's okay. Well, you can think of this as how much of the valuation is out in the tails. So if inelastic demand really means people have spread out valuations for the thing, curvature is really a measure of something like kurtosis. It's like how much is out in the tails. And in fact, you can relate this to our notions of fat tails before. Anytime you have fat tails, and the fatter tails you have, the more negative is going to be 1 over the elasticity of marginal surplus. In fact, the elasticity of marginal surplus is equal to the negative of that parameter alpha that we had before. And so 1 over negative alpha is equal to this. And so as you get towards Zipf's law, for example, this is going to get very, very large. so income tends, so when income generates values, when there's goods that are valued more by the rich than they are by others, and the more that they're more valued by the rich, the more that this is going to be large. Or if a good has very niche appeal, then this is going to be very large. So let me give you a graphical illustration of this. So here's a concave demand function, and here's its marginal revenue curve, which is diverging at an increasing rate from the demand curve. That means that for a small increase in marginal cost, the increase in price is going to be much smaller because we move more up the marginal revenue curve than we do up the demand curve. On the other hand, when we have a constant elasticity demand like this, because these are converging, a small increase in the marginal cost curve leads us to move farther along the farther along the demand curve than it does along the marginal revenue curve, and therefore leads to twice as large of an increase in price as it did an increase in marginal cost. Similarly, changes in the shape of the marginal cost function, which effectively change the elasticity of supply, will affect this as well. So if we have an upward sloping marginal cost curve, which makes somewhat inelastic supply, then an increase in marginal cost leads to a smaller move in the quantities and therefore a small change in price. Whereas if you have declining marginal cost, as you often do in natural monopolies, then an increase, that's like a negative elasticity of supply, then an increase in marginal cost leads to a bigger change in quantities and therefore a bigger change in price. Okay, that's it for today.